Hey everybody, I have a contrived looking inequality, and it is sort of contrived. It does depend on a particular result from calculus. Now, by ln x, I just mean, it's called the natural log. I mean this log base e. In many cases, the parentheses are dropped. I like reminding everybody that we are dealing with functions, but I'll go ahead and use the parentheses anyway. It's log base e of x, but usually the parentheses don't appear there. Okay, so that's what it means. It means base e, and that is actually important. Remember, base e is approximately 2.718. Okay, it's an irrational number, so I'll just write out these first three significant digits here. Okay, now it turns out it's important that the base e is important, because if it's a lower base, the inequality I'm about to show you doesn't hold. Okay, now this is the fact that I want to write. I'll just call it fact. I'm not going to try to prove it. If you imagine the Taylor series for e to the t, 1 and t are the first two terms, and then it alternates, I think, or it alternates. But it's kind of easy to believe. And also graphically, if you want to take a look at it from a graph point of view, let's just draw the t-axis here. Okay. Now let's draw this is a simple line to draw. It crosses at the y-intercept is 0, 1. It's easy for the line. I'm doing the line here. And also the x-intercept happens down here at and this is just intuition. It's not a rigorous proof by any stretch. A lot of people will scream and cry that a graph is not a proof, but it makes it easy to believe this result. Okay, fairly easy. Okay, now so we have this line passing through these 2 points here. Okay, which is the line t plus 1. Okay, y is it, you want to call it, I'm not going to insert the extra variable, but you can call this the y-axis. This is y is equal to t plus 1. Okay, now the exponential function, it turns out that it looks something like this, and it misses, and it stays underneath, and then right there, so it looks about like that for e. But if it weren't base e, it would dip underneath in here somewhere, I believe. Okay, so it's not for any exponential function. In fact, any base less than e, you would have some negativity here. In other words, the exponential graph would be underneath the line here. And this is a very crude graph. But if you want to call this e to the t here, and then t plus 1, it's fairly believable that this is true for all t, provided the base is e. Now, that's not intuitive at all, okay? And I'm going to do some videos on that maybe at some point. But anyway, this is the fact we're going to use. We're going to treat it as the truth. And it is the truth. It's just I didn't provide you with a rigorous proof. Calculus can prove it, I think, or you use Taylor series. But now, so a natural try based on this result is just to substitute t is equal to ln. And this is where the contrived part is. So you see, you can just see I just substituted in here directly. In this fact becomes this statement right here. Okay, now since e and ln are inverse functions, what you would get from here would be x to the minus 3/8. And I did use laws of exponents, the negative law of exponents. All right, I'm sure you're familiar with that. But so we get, owing to the fact that e and ln are inverses, this is true. Okay, now right here you're going to have greater than or equal to. Now you're using a property, kind of a dual property for logarithms. The minus 3/8 as an exponent drifts out to the front. And I go ahead and break down and just call it ln x, like everybody does, plus 1. Okay, then you can see what is it we're trying to prove. Excuse me. We're trying to prove that 1 over 3 to the 8ths, and again, this is the very same thing as x to the minus 3/8. Okay, this term right here, this term is equal to this term. So all you got to do is bring this back over to the other side, and you get x to the minus 3/8 plus 3/8 ln x, bringing that to the other side of the inequality. Is greater than or equal to 1. And so I didn't even lift a finger on this problem. You see, I used this powerful results that's fairly believable based on just sketching a rough graph. But again, it's more interesting to show that any base between 1 and e would result in the graph dipping below the line y equals t plus 1. So that would be a nice inequality question, to try to prove, just using the methods of calculus and the first derivative test, maybe the concavity, all that kind of stuff, And I'll try to remember and do something like that. But anyway, this is QED time. Thus we have demonstrated. And again, nothing too exciting here other than it takes a fairly well-known result from calculus and converts it to a logarithmic result. Okay, and I'm just double checking to make sure I get it right. Yeah, that's what we're trying to prove. Okay, all right. Thanks for viewing.